my name is Brian. I'm one of the instructors in J6, and I'm here to introduce Rishaan. So I've had the pleasure of working with Rishaan for the past 6 weeks now, and he's been working on a ton of different things, starting with his base project, and the modifications. And I'm going to tell a quick story about one of the modifications. So one day he was like, I'm done with my base project, and now I want to add some more, and he brought up this idea of an LED. I was like, all right, go for it. We're going to do some research on these schematics online and take a look at what we can do. So next thing I know, on the whiteboard, there's like 6 circuits drawn, and he's learned like so many different equations, put them all together. And I go back to my computer, and I look back up, and he's soldering it all together. And then the next thing I know, it's done. And he's like, Brian, this LED is working now. So without further ado, he can show you his LED. And yeah, give it up for Rishaan.
Hello everybody, I am Rishaan and I'm going to be showing you my IoT pollution monitor. This IoT pollution monitor has 2 sensors, a temperature and humidity sensor and an air quality monitor sensor. It takes this data and it uploads it online to a web browser called Adafruit.io. I chose this project to learn about the Internet of Things, which is taking any data from hardware and uploading it online to software. Now I will show you a demo of the project. The project is currently functioning, and it sends data to Adafruit.io every 2 minutes. So I'm going to go ahead and show you Adafruit.io. So this is the Adafruit.io dashboard. It has 4 data feeds. This is the AQI category, the current temperature, the current humidity, and the air quality. I also added a map which shows where the air quality monitor is working, which it shows right here. It's in San Jose. There are also 2 line graphs at the bottom which show the air quality over 1 day and 1 week. Now I will show you the parts of the project. There we go. So, as you can see, there is one OLED screen over here, and there is the LED over there. This is the ESP32, the Feather M4 Express, and it uses an airlift feather wing, which connects to the Wi-Fi. Below it, it has a temperature sensor and the air quality monitor sensor. To get accurate data, it does have 6 small holes that allow the air to pass through. So, the 2 modifications I made were the OLED screen and the LED. These modifications show the data right where the air quality monitor is. I chose to make these modifications so that I can see all of the data just from where I placed the air quality monitor, so I don't have to go directly online to find the data all the time. This is convenient because in case there is a Wi-Fi issue, this will always be updated, the OLED screen and the LED, whereas Adafruit.io might not update. Some challenges I faced with this project were connecting to Adafruit.io. Adafruit.io connection used to drop about 50% of the time. So to fix this, I had to research on these 2 boards, the Feather M4 Express and the Airlift Feather Wing. I found out that these 2 had, they both connect via SPI, and because of this, they are able to act like an ESP32. So I had to eventually replace these boards, and after that, it was working pretty smoothly. After that, it took me to another challenge, which was adding the OLED screen. When I added the OLED screen, I wired it directly to the Feather M4 Express. This caused a power issue, and it could not connect to Adafruit.io anymore. To fix this, I had to desolder everything, and I connected it via stem and QT wires, which is way more cleaner than regular soldering. There are a lot of things I learned here at Bootcamp. I learned how to do wiring, splicing, which I did with this cable, the cable over here, and I also learned about ESP32s, which I never worked with before. I have also learned a major topic, which Brian was talking about, circuits and voltage dividers. With these voltage dividers, I learned how to use ohm resistors properly. At first, I would just take any resistor and I would just plug it in directly to the wire and hope it would work. This is not going to work because if the voltage is too high, the board is going to get fried and it is going to stop working. If it's too low, the project parts are not going to work. My next steps for this project are to replace these two boards and use the ESP32, just one board, so that the add-through I/O connection can become stronger and this project can function over a longer period of time. I also hope to do more hardware projects, and with my IoT experience, I would like to use this to make any hardware or any project come online and I can control it from online. For example, any car, I can just control from an online app. Thank you. Any questions?
How did you decide on kind of like the design of your enclosure?
Okay, so for my case, at first there was a separate add-through I/O case. I could have just used that, but I decided to 3D print my own with a leaf environmental design on the top. And on the bottom, I did 3D print it so it has more clearance room for the modifications. Yes.
You also get banned on the website.
And on the website? No, I do not get banned on the website. Any other questions?
So, radio place is these are like a static location, right?
Yes.
So you can have a wide connection as well, but you need to have wireless connection.
Can you say that again?
It can be a wired connection to the device so that you can, have more accurate connection.
Yes, you can wire it to the device, it will be more accurate. But it does also work offline. You do not have to wire it directly. You can just wire it straight to a wall and it will function properly.
What is the power source? Does it use a battery or?
No, it just needs to connect to any power, so you can just do it on firewall, that works. Or you could add in a separate power supply.
You said you have to desolder the component. You said that was most clear.
Yes. So the OLED screen,
What you mean by clean?
so clean meaning when you have to solder, I had to solder with 4 separate wires. Where the stem and QT wire, all of the 4 wires are combined, so I just have to plug it in instead of solder each one separately.
The quality of signals will come better.
Yeah.
How much air do you need to let in before?
It just needs to have a constant airflow. It cannot be stuck with a constant air. So if I did not have 6 holes and I just closed it, it would not have any air. The air would stay trapped and it would have a constant air quality. But just keeping it like this and having a few holes, it just lets the air circle through. And the air quality sensor has a small fan which allows it to take in air and take out air.
What's the true definition of the quality that they use that line labels?
So air quality, it takes the particles in the air. If there are very big particles, that is a sign of a high air quality, which it's dangerous for humans to breathe in those particles. It uses a laser to look at those particles and find the size.
What's the ppm of the set? How many parts per minute?
How many parts per minute?
Per minute for the air part? For the particles to be considered more or less, is there a
Yes.
threshold?
No, so that's what, everything has a different category. I don't know those on top of my head, but there's one for good, it's like about 0 to 5, and then for water it's like 5 to 12.